Okay, so today we are going to look at perimeter and area of trapezoids and kites. So last class we talked about the properties of trapezoids, and now we're going to use that to help us figure out area and perimeter. So this first part, we're just going to look at regular trapezoids. Number one wants us to plot these coordinates, so I already have that done over here on our coordinate plane, A, B, C, and D. So that's the name of this shape. Should be pretty obvious that this is going to be a trapezoid, since it's something that we've talked about before. What lets us know is that AB and DC are parallel with each other. So if you remember that little symbol right there, it means that they're parallel. And trapezoids have exactly one pair of parallel sides. So 3 and 4 are really the big things we need to know, which is going to be what's the perimeter and what's the area. So we're in a coordinate plane, so as you can probably guess, distance formula is going to help us out here. So I'm going to write that up here so we can have it. Nice thing about this trapezoid is that some of these sides are on straight lines, meaning we don't have to use distance formula in every single line. So if I look at my trapezoid AB, for example, I can just count how many spaces there are between A and B, and that's going to help me figure out the length of it. So if I count, that's going to be 6. BC, if I count, that's going to be 6 as well, and then DC down here is 8. So that's 3 of my 4 sides already taken care of. So now it's AD that I'm going to have to use my distance formula on, because I can't just count the sides there. So I can get that thrown into distance formula, and that will get me my answer. So I'll have it written out, and then of course we can just plug all this into our calculator. We'll go to the nearest tenth here. So it'll look like that. So when you plug all of that into your calculator, you will get 6.3. So 6.3 is going to be the length of AD. It should make sense. It's going to be a little bit bigger than BC. And then, of course, just like all of the other times we've done perimeter, we're going to add all of our sides together, so 6, 6, 8, and then our little decimal there. So we're going to get 23 or 26.3 right there for our perimeter. So really we just have to use distance formula once and add everything up. When it comes to area, that's actually going to be a little bit easier here. So we'll do that here in green. So our formula for area, it's 1/2 base 1 plus base 2 times the height. So of those 3 things I need to get, base 1, base 2, and the height, I already have 2 of them, that being our bases. So that's 6 and the 8. So I'm going to have 1/2 6 plus 8 right there. So now the height, I need to figure out what that's going to be. And to figure out the height, it's going to be the distance between the bases. Or if you want to look at your legs, it's going to be the vertical one of the 2, which is going to be 6. That's also going to represent our height, so make a little note of that. So I just write that 6 there, so that's something that you can plug into your calculator if you do it all correctly. But your final answer here will be 42. Of course, we'll have some units here, so this will be units squared, and of course that would just be units there. So if we have a regular trapezoid like this in a coordinate plane, here's how we would get area and perimeter. Okay, so this next part talks about the mid-segment, and just so we're on the same page, mid-segment is the same thing as median, so we saw that in our flip book last lesson, so we talked about what it is and even worked some problems with it. So it's right here, and it's the same definition we have. It's a segment that connects the midpoints of the legs of a trapezoid, so it's going to be really important for us to know and recognize that. So number 5 wants us to draw a mid-segment in part 1 and label the points K and L. So if we're going to draw a mid-segment, we need to know, of course, what our midpoints are going to be. So when I look at B and C, I can plug those into midpoint formula to get my answer. And if you don't remember midpoint formula, x1 plus x2 divided by 2, y1 plus y2 divided by 2. Now in the case of BC, it should be pretty easy to count. We saw that this was 6 in the previous problem, so this right here is going to be our midpoint. So that's going to be L right there. As for AD, we might have to use midpoint formula on that. Regardless, what we'll see, it's going to be at this location right here. So let's write that coordinate down. K is going to be at -4, -1. L is going to be at 3, 1. So we can use midpoint formula If it's one like BC, where it's pretty easy to see that, oh, we're 6, so it's going to be halfway at 3, we can use that little shortcut there. If we connect this together like that, and then there you go, there is your midpoint. So number 6 down here, it asks the relationships that we have with the mid-segment and the base. So there's really 2 things that we get from this. They are all parallel. So the bases and the mid-segment are all parallel with each other. They're never going to intersect. And as we talked about last time, the median is the average of the bases. So this is stuff that we looked at last class with that little tab on our flip book. So it's kind of just a nice little reminder about a mid-segment or a median. Okay, so next we're going to take a look at an isosceles trapezoid. So first thing we need to do, of course, would be to plot our points. After we do that, your figure should look like what I have in the coordinate plane. Number 8 asks the name of this shape, so it's kind of obvious it's going to be an isosceles trapezoid. However, it wants us to explain, and there's one way that we can prove that this is an isosceles trapezoid. So what makes it different compared to a regular trapezoid is that the legs are congruent with one another. So that's what we need to prove, is that these legs of this isosceles trapezoid are congruent. So if we do that, that proves it's an isosceles trapezoid. So your legs are going to be AD and AB. So that and that. So once again, we're going to use our favorite formula, that being distance formula. So you would just plug AD and BC into each of those. So of course, if they equal each other, then they are going to be congruent in an isosceles trapezoid, and then if not, then they're not going to be. To save you the trouble, if you go and plug all of that in, you're going to get 7.2 for each of those, proving that this is in fact an isosceles triangle. So from here, we can go and get perimeter and area, and I want you to try this one on your own. So I want you to pause and try to figure out the area and perimeter on your own. Remember, you can count the sides for those bases, so pause the video now and try it for yourself. So what we're going to do for our perimeter, if we count, that's going to be 6, that's going to be 14 down there. So if we add all of those up, that's going to give us what our perimeter is. We're going to get 34.4 units. Area, we're going to use our same formula as before. So our bases are going to be 6 and 14. Where this gets a little different and maybe a little tricky if we're not paying attention is this height. So with the trapezoid we had before, one of the legs was the height. In this case, it's not going to be the case because these are slanted. So to get our height, it's going to be the difference between our bases. Remember, it has to be a vertical line. And if we count those, we get 6. And then once we plug that into our calculator, we're going to get 60 units squared. So this is the first part of this page, the first sheet. We're going to talk about trapezoids. So if you click on the next video, the part 2, we're going to talk about kites and then those problems below. So go ahead and click over to that.